This is a typical block, and we've replicated it 3 times on my location and 5 times in the Sierras. So we have 2 climates represented in this study. So the exact same compost, as Jeff said, was applied on the randomly assigned plots. We have a control, a compost. We used the Omen plow experiment, and I was very careful to use a laser and plowed on a exactly level line so that no water would migrate on and off of the plot. We were looking at infiltration in this case here. And then we mixed it up. We put compost on the plowed plots as well. And this was all done on a background of grazing. And I'll flip backwards here for a second. This is an hour after I put the cows in the field 5 months later, and they obviously preferred the composted plots. This was significant to us. Do you want to comment on that?
Well, it was really quite a dramatic response on the part of the cows to the compost. And we see 2 possible explanations for that. One, there was a lot more biomass on the composted plots, so there was a lot more to eat on those plots. The species composition was at least apparently quite different. We had a lot of tall, very lush, but basically weedy annuals on the composted plots, and the cows really liked that stuff in the early spring. So that's probably what's going on there. There's also, of course, a nutritional difference that we didn't actually measure, but we assume was there, and the cows definitely seem to appreciate that.
So prior to every treatment, we go out and do a soil sampling down to a meter deep, typically 3 or 9 locations actually per plot. So in my entry hall now are over 1,000 soil samples waiting to be dried and analyzed at the laboratory, but we have a phenomenal data set that we're accomplishing. Every week we use an infrared gas analyzer to measure the respiration of carbon dioxide from the soil system, as well as monthly samplings of nitrous oxide and methane. And we have full-time data loggers measuring temperature and moisture in all of the plots as well. And the result of that is we have a 2-year data set now, and Jeff should speak to this.
Well, again, as I kind of said before, we saw a real increase in total production on the compost plots. Not a big surprise, but I think it's important in terms of understanding what some of the benefits of increasing soil carbon can be. This now, as John said, is a 2-year data set, and we applied compost once to these plots, and we're seeing still into this year a very significant difference in production, residual from that one-time application. So our intention is to just follow this one application over time and see just how long this pulse of compost or pulse of carbon will result in an increase in forage production for it.
In our area, the dairies take these large trucks and drive on these insanely steep hillsides spreading wet dairy manure. So the question of whether people could put compost out on the landscape, physically, I'm watching guys do a much more difficult job. The rate of application was just 1/2 inch, and I was the one who put it out there. I have a broadcast spreader, and it just blows it out the side. It's really easy to do. So this dusting of 1/2 inch of compost 2 years later has this kind of effect on the rangeland system. That's amazing to me. Oh, this is a good one. Why don't you go for this?
All right. So this I think is pretty interesting. I'm going to talk about this a little bit more later on, but we put on the equivalent of 14 tons of carbon per hectare. We saw an increase in soil carbon of 14.8 metric tons. So we had basically a 1 metric ton increase above and beyond what we applied. And in that same period of time, we saw a decline in soil carbon on the control plots. So what we're seeing here is a response of the system that is above and beyond what we actually physically applied. This graph just shows what happened on the compost plot versus the control in terms of above ground production. This is just above ground production. And we saw a real increase in above ground biomass. Now, that 0 is our baseline. That's where we started. So we're not talking about negative growth on the control. We're talking about less growth than the previous year. But on the compost plot, we saw this increase of about a metric ton per hectare. So this is a real change in terms of forage productivity with a very small application of compost. So the take home here is that we added about 15 tons of carbon per hectare. We didn't see any methane or nitrous oxide emissions from that. We applied about half an inch of compost. It was relatively easy and cheap to do. It increased our forage production by a ton per acre. Actually, that should be per hectare, sorry. And it buffered soil temperature, which was very interesting. We saw slightly warmer temperatures in the wintertime, actually 10 degrees centigrade warmer in the winter, and 10 degrees centigrade cooler in the summer. And our moisture conditions were much more favorable on the compost plots.
So this is an exciting slide. If you look at that 15 tons we put out per hectare, that didn't mean anything to me. It was, I did it, it was easy to do. But when you look at the California Energy Commission website and look at the inventory of emissions, and California is the 12th largest source of emissions on planet Earth. We put out more than most countries do. And when you look at the numbers applied on half of California's landscape in terms of a half-inch dusting of compost, and we'll talk about whether that's reasonable or not, half of California's manageable landscape, at the rate we did, would more than offset all of California's emissions every year. Just gonna stop there. Okay. Thank you. I was excited too. So if you expand that outward, maybe a smaller change on a greater landscape, and we saw several versions of this map earlier today, it would have a phenomenal effect on climate change. And that's what we're really excited about. So this is replicable, scalable, and broadly applicable.